Welcome back to your Semester 1 Algebra 1 final review. We are on the strangely labeled problem 14.5. And that's because we liked problem 14, but we wanted to give you a different version of it that maybe did things in a different way, but it was so closely related that we called it 14.5. As always, these numbers could change from year to year, but either way, let's get to it. We have a linear function, and of course the word hiding in linear is line, not ear, though ear is there. A line passes through the points 0, 4, and -1, -8. And actually let's do this in colors. So we have a line that passes through these 2 points. And then we have a second function, and that's also going to be a linear function. We can see it in standard or almost standard form over here. And so the question is actually pretty complicated. What is the slope of the function? And actually I think that's our final goal. What is the slope of the function? So all of these down here are slopes, which we label with m, the movement of our line. What is the slope of the function with the greater y-intercept? Oof. So I think there's 2 steps to this problem. Step 1 is going to be find the y-intercept for each function. And then step 2, which is going to be way down at the end, step 2, let's do in green. Step 2 is, of course, find the slope. Then we only have to find one slope here. It's going to be of the function and of the function with the greater y-intercept. Find the slope of the function with the greater y-intercept. So we'll come back to step 2 and let's go to step 1, because first we need to determine the y-intercept for the yellow function and the red function. Whichever one's greater, well then we're going to find the slope. So let's find the y-intercept for each. Well, the first one's actually pretty easy. The one in yellow, 0, 4, and -1, -8. We already know the y-intercept here. That's exciting because we need to know at this point in time that the y-intercept is, of course, on the y-axis, and pick a point on the y-axis. Wherever it is, it's going to be 0. You don't move left or right here. It's going to be 0, some number. Oh, and look, they gave us a number 0, some number. So in this case, my y-intercept for the yellow function has to be 4. That was easy. Cool. Let's look at the other function. The other function is -2x plus 3y equals 6. Now there are 2 ways to find the y-intercept here. I'm going to show you one way. And then actually I'm going to show you a second way in just a second. So one way to find a y-intercept anytime ever to find a y-intercept is we know a y-intercept, and we just saw this above, has to be 0, something. So let's take this equation and let's replace the x. This is an x, right? 0, something. Let's replace the x with 0. And then we need to simplify the left side and eventually isolate y. Simplifying the left side, -2 times 0 is 0. But hopefully you've reached this stage of math that you know you don't really need to write that 0. So we get 3y equals 6. And then one way you can think about this is 3 times what equals 6. And hopefully you're saying, ooh, 3 times, oh, I think I know that 3 times something is 6. But the other way is you can say, well, 3 is multiplying times y. So we divide both sides by 3. And so we find that y equals 2. So our y-intercept here is 2. Taking a peek at these 2 y-intercepts, we have a y-intercept of 4 and a y-intercept of 2. All right. Well, I did tell you I'd show you a different way to find the y-intercept if you didn't want to put it that way. The other way to find the y-intercept is you could just isolate y. Because if we isolate y, what we're really doing in this equation is we're putting the equation into slope-intercept form. And we know slope-intercept form, just a reminder down here, m times x plus b. The b is the y-intercept. So when y is isolated, it becomes slope-intercept form, and we'll know the y-intercept. So let's go ahead and isolate y up here. There are 2 things happening to y. Positive 3 is multiplying, and 2x is actually subtracting. It's kind of weird. You're like, isn't -2x adding? And in some ways it is, but I always like to think of the sign to the left as telling us what this is doing. So this is being subtracted. All right, so let's go ahead and add 2x to each side here. Actually, even easier than that, we don't have to combine 6 and 2x. They're not like terms. The 2x is just going to sit. I like to put it in front. You can put it at the end, but in front is going to more match this mx plus b. So 2x, and then this is a positive 6. Last but not least, we would need to probably remove that 3 that's multiplying. And whenever we multiply or divide, we have to distribute that value, right? So I'm distributing it to every number. The 2 divided by 3, that doesn't go nicely, so we just keep it as a fraction. Mathematics is all about laziness. Some people call it efficiency. I think it's laziness. And then we have 6 divided by 3, and 6 divided by 3 is 2. And look, it is the same y-intercept. So you can ask yourself, what would you prefer to do? Would you prefer to plug in 0 and do one operation, or would you prefer to do 2 operations? And some of you may actually prefer just putting this into slope-intercept form, others may not, and that's okay. But back to the original question. We had to find the y-intercept for each function, and we did. The first one in yellow has a y-intercept of 4, the one in red has a y-intercept of 2. Then it says, cool, now find the slope of the function with the greater y-intercept. Well, out of these 2 y-intercepts, which is greater, 4 or 2? And I think 4 is the greater y-intercept here, isn't it? So what they're really asking is, they're saying we have a function that passes through 0, 4, and -1, -8. We need to find the slope of that function, because that's the function with the greater y-intercept. All right, well, how do we find the slope? That's just our slope formula. How exciting. We've seen this before. y2 minus y sub 1. And I always put these in parentheses. You want to do that so that you don't lose any negative signs here. We should probably label our points. Let's maybe start with the x's here. Those x's come first, and then we have the y's that come second. But this is confusing because I said, tell me the x in this function. You might say, well, wait, is the x 0 or is it -1? Well, the x is both of them, so let's label them so we know the difference. Let's call this x sub 1 because it's the x that comes first, and then x sub 2 over here. Same thing with the y's. First y, second y. And now we can fill in our slope formula. It's probably a good idea to start with just the parentheses and the minus that separates them, or maybe connects them, so that way we don't lose anything. And then y sub 2, -8, y sub 1, 4, x sub 2, -1, x sub 1, 0. And let's continue through. Now we can start dropping our parentheses. -8 minus 4 over -1 minus 0. -8 minus 4 is -12. -1 minus 0 is -1. Then we're pretty much done. So we say, okay, does that match any of our answers? But it doesn't. Drat. But it seems like 12 is probably the likely candidate. How did they get there? Well, a negative divided by a negative is, of course, a positive. 12 divided by 1, we don't need to put the 1, or you can think that 12 divided by 1 is 12. And so we find that the slope of the function with the greater y-intercept is 12. Thank you for tuning in. Keep being successful on this Algebra 1 semester review. If you can go through this no problem, you'll go through the final no problem. I promise ya. Keep practicing, and we'll see you back for our next question.